Alright, welcome to checkpoint 13. We're going to go straight to the bottom, see if we can get through the majority of these. So, lesson 13. What is the measure of angle F? So, I'm looking here and I'm noticing that this has a circle with 2 tick marks. This has a circle with 2 tick marks. That means that they are the same angle measure. That means angle E is 127 degrees. I'm also noticing the angle B has the circle with a 1 tick mark. Angle D has the circle with a 1 tick mark. That means they are the same angle. That means angle B is 15 degrees. So, leaving that, putting that information together, we also know that by the triangle sum theorem that all of the angles within a triangle have to add up to 180 degrees. So what we're going to do is we have measure of angle F. So we have 15 degrees plus 127 plus F is going to equal 180 degrees. So we need to simplify for F, so we're going to combine 15 and 127. Take that answer from 180. So 15 and 127 is 142 plus F equal to 180. And I'm just writing out what I said. So we combined the 2 angles we knew the measure of. And then we are going to take that from 180. So 142 is the subtraction property of equality. So then we have 142 minus 142 is 0 plus F. And that's going to equal 180 minus 142 is going to give us 38 degrees. So 0 plus F is F equals 38 degrees. So the measure of angle F is 38 degrees. Question 9. Use the information diagram and prove to fill in the blanks. We're given that M is parallel to N. We need to prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees. We need to prove that the measure within the triangle is actually 180 degrees. So I'm scrolling through this and it's an example proof triangle sum theorem. And what is given here is we are given the line YZ is parallel to the line BC. The reason we know that is because it has 2 chevrons on each other. So this is very similar, the setup on this. So we're going to step through this. Measure of angle 1 plus the measure of angle 5 is equal to the measure of angle ABE. ABE. They're saying 1 and 5 make ABE. That's the angle addition postulate. And then angle ABE and angle 4 are blank. Definition of a blank. Okay, so they want to know what is angle 4 and angle 5's relationship. Well, this goes back to your definitions, and right now I'm noticing that angle 5 and angle 4 are on the same line. So if I were to draw, I could draw half a circle from one side of angle 5 to the other side to angle 4. And that means we could draw a straight line. So we have a linear pair for x. That is the definition of our linear pair. And then we know that they add up to 180 degrees, which is our linear pair postulate. And then it continues on through it. So, since this is correct, I would add this to my own notes if I were a student and use it as an example for the proofs. And I would write just copy it down so I knew what it was. So question 8, what is the measure of angle 1? Okay, we need to know our relationship. So the first thing I'm noticing is we have 45 degrees, and a blank here. And I'm also noticing that CAB forms a triangle. So inside a triangle is 180 degrees, so I have 45 plus 45. That's the angles within the triangle, plus C. That's going to equal 180 degrees. So 45 plus 45 is 90, plus C equals 180. Then we're going to use the subtraction property of equality and subtract 90 from both sides. 90 minus 90 is 0, plus C is equal to 180 minus 90 is 90. 0 plus C is C. So C is equal to 90 degrees right here. This inside measures 90 degrees. And now we want to find the measure of angle 1. Well, I'm also noticing that part of this is a straight line. And that straight line is split in two, and so I have a linear pair because angle AC to B is 90 degrees, and angle 1 makes up the other half of that straight line. So the linear pair part is going to be, this was 90, so 90 plus what? I'm not going to use 1 because that would be as the symbol, because that would just be confusing. So the linear pair is 90 plus what is equal 180. So we can think that one through and we don't have to do the algebra. 90 and 90 is 180. So I know that the measure of angle 1 is also 90 degrees. So to avoid rejection, the first one is saying thank you for saying that. And if that doesn't work, then you move on to step 2, which is to ask them to repeat it. And if that doesn't work, then you would ask, why did you say that? Are you trying to hurt my feelings? And at this point, the majority of people will say, no, I just thought you would like to know that I think you should have long hair. Or if they were really writing you about that presentation that you gave, they would most likely say, no, I'm not trying to hurt your feelings. I'm just trying to help you be better at a presentation and let you know that maybe you need more practice. So that's the third step, is just to ask, why did they say it? What was their intent in it on your, in stating that to you? So that's the third step, and we'll find out what the fourth one is next time. So question 6, use the information diagram and proof to fill in the blanks. given segment AB is congruent to segment CD, prove that measure of angle 1 is equal to measure of angle 2. Okay, so we are only given that AB is congruent to CD. Alright, so AB is congruent to CB, that's given. Draw BD, the bisector of angle B. Each angle has one unique angle bisector. Okay, so they're creating this right here so that they know the angle bisector means that cut that angle in half, and if you cut something in half, each portion is the same. So then they know that angle 3 is congruent to angle 4. Why do they know that? It is a definition of the angle bisector. And then they go on to state that segment BD is congruent to segment BD. That's a reflexive property. And then they have triangle ABD is congruent to triangle CBD. So ABD in this order, congruent to triangle CBD in that order. So that is because we have side AB is congruent to its corresponding part CB. We have angle 3 congruent to angle 4. That is corresponding angle. And then we have side BD is congruent to itself because it's the same side. So we have a side, an angle, and a side. The corresponding side, angle, and a side. So we have side, angle, side. Congruence postulate. And then it goes on to explain the rest of it. Okay, question 5. What is the measure of angle 1? And then we're going to enter your answer as a number that correctly fills in the blank in the previous sentence. So, angle 1 is right here. We need to find the relationship to find this. There's two ways to go about it. The fastest way is the triangle exterior angle theorem. It means the measure of an exterior angle of a triangle is equal to the sum of the measures of the non-adjacent interior angles. So that means we have the exterior angle right here, angle 1, like in this diagram right here, and the two non-adjacent interior angles. Non-adjacent means not touching. So angle B and angle A are not touching angle 1, just like angle A and angle D were not touching this angle formed by ACB. So we have 90 degrees, which is B, plus 45, which is A, and that is going to equal 125. Wait, 135. So we know then that angle 1 is 125 degrees by the triangle exterior angle theorem. The other way we can do it is we can find out what this angle is. Angle BCA is going to equal 180 degrees minus the sum of these two angles, which was 90 plus 45. So then we have 180 minus 135, which equals 45 degrees. So then we knew that this angle would be 45 degrees. And since these two angles form a straight line, they're a linear pair, that means that they would add up to 180 degrees. So if we have 180 degrees, and we take 45 away from it, what is left? That would be 135. Well, there's the two ways you could do question 5 and end up with the same solution. Okay, so question 4. Two sides of a triangle both have length 6 centimeters. Which of the following measures are possible measures of the triangle's 3 angles? Okay, you might be thinking, what do side lengths have to do with angle measures? That was a beautiful triangle. Let me try it again. It might be. Okay, so we have two sides, 6 centimeters. Which of the following are possible measures of the triangle's 3 angles? Well, if we know that the triangle has 2 of the same angles, right here in the base angle theorem, and the converse of the base angle theorem, it says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So then we know that this angle and this angle, they're opposites. Or let me draw you another triangle since that one looks the exact same as the one in the picture. We could have it like this, and we could say these two sides are the same. So what are the base angles then? The ones opposite. So if I were to take the 6 and draw a line straight across, that's the opposite angle. Take this 6, draw a line straight across, that's the opposite angle. So that means these two angles have to be the same. Now it doesn't matter what this third angle is, as long as all 3 of these add up to 180 degrees. So we know that at least 2 of them have to be the same. Could all 3? Yeah, but at least 2 of them. So what is 60 plus 60 plus 60? That is 180. And at least 2 of them are the same. So that could be a possibility. And look at this, 125, 20, and 35. Can't be an option because none of the angles are the same. 1976 and 85. Can't be an option because none of the, it doesn't have 2 of the same angle. 30, 60, 90. Can't be an option because it doesn't have 2 of the same angle. 90 degrees, 45 degrees, 45 degrees. 2 of the same angle, 45 and 45. Now does it total 180? 90, 45, and 45 does equal 180. The next option that we could have is possible, 100 and 40 and 40. Well, they have 2 of the same angles. 40 and 40 is 80. 80 and 100 is 180. So those are our options that we could have if we know that 2 sides of a triangle both have the same length.